so adding and subtracting rational expressions is what we're working on today. And we are going to find what's called the LCM. Do you guys remember what LCM stands for? Least common multiple, okay? We'll have some LCMs, we'll have some LCDs, least common denominator. And in order to add fractions, you guys just told me you have to have a common denominator. Alright, I'm going to do an example for you, and then I'm going to give you one to do on here, okay? So, let's say you had, we'll do a quick one. We'll do 1 over 3 plus 5 over 6. Okay, so then what would be your LCM, the least common multiple?
3.
Okay, good. So you just multiply by 2 over 2. So this would be 2 over 6 plus 5 over 6, which would give you 7 over 6. Okay, now I'm going to give you a different type. Okay, so I want you to add 11 twelfths plus 3 eighths. Like I said, this one's a little bit different. Okay, so we're going to find the least common multiple. What's the least common multiple between 12 and 8? 24. So if the LCM is 24, we multiply to get there. What do we multiply by 8 to get to 24? 3 over 3. To multiply from 12, you multiply by 2 over 2. And why are we allowed to do this? Why can I multiply by 2 over 2? It's equal to 1. And if you multiply something by 1, what do you get? Itself, the same thing. So I'm not changing the value. That's why I'm allowed to do this, okay? So 2 times 11 is 22. This is over 24. 3 times 3 is 9. And then this won't reduce, but you do have to check to see if fractions do reduce, okay? So that's going to be something that we're doing. All right, for example 1, it says to add or subtract, and then we do have to identify x values for which the expression is undefined. Okay, so remember with what we did yesterday, that means we have to find where the denominator equals 0, because we know that's not allowed. All right, so for A, we have x minus 3 over x plus 4 plus x minus 2 over x plus 4. So we're warming up here. Okay. You already have the LCM, right? Okay, so if they have the same denominator, you can just add your like terms. Okay, so if we add our like terms, x and x is going to be 2x, negative 3 minus 2, negative 5, and then the denominator stays the same. Okay, so you add like terms. Remember, you only add the numerator, denominator stays the same. Now we have to find out what x can't be. So if the denominator can't be 0, x plus 4 can't be 0, so what can x not be?
Negative 4.
Yep, x cannot be negative 4. If it was, that would produce the no solution if you were to solve it. Okay, so we're saying that is our restriction. Okay, now for B, we're going to do some subtraction. So 3x minus 4 over x squared plus 1 minus 6x plus 1 over x squared plus 1. So right away, we do notice they have the same denominator. What you have to watch out for when you have a negative is you have to do what? Yep, you have to distribute that negative. Okay? So distribute. Okay, the minus sign or the negative. Okay, and you can absolutely do that part in your head when you're doing this on your homework. Sometimes what I'll do is this, so I remember, and the denominator is the same. so this is negative 6x, and then when I distribute here, it's minus 1. Now I can combine my like terms. Okay, so I have 3x minus 6x. What's that going to be? Negative 3x. And then I have negative 4 minus 1, negative 5. And then it's over x squared plus 1. All right, so now that I have this, I'm going to find where the denominator equals 0. Okay, so I'm going to set x squared plus 1 equal to 0, and I'm going to solve for x. So go ahead and try that. All right, so when you solved here, you should have subtracted over the 1, and then when you take the square root, remember, this produces an imaginary answer. So this is a non-real solution. If that happens, your restrictions, you don't have to include imaginary numbers. So for this, it's defined for all x values. So that's what we say, defined for all x values. So we only have to worry about the real number values. So that could happen. It could be there are no restrictions, and that's an example. All right, example 2, we're going to find the LCM, which means the least common multiple. Okay, so we did this a couple times today already, right? The LCM between 12 and 8 was 24. Okay, so, yeah, if you guys are doing pictures today, when it's your time, you can just go, okay? So the LCM, see how the LCM for 12 and 8 was 24? The LCM for 3 and 6 was, what was the LCM for 3 and 6? 6. Okay, so it has to be as large as the biggest number between the two. Yeah. You can go a minute before. You can go 2 minutes before, whatever time it says. Yeah. All right, so your LCM for this, for A, we have 4x squared, y cubed, and 6x to the 4th, y to the 5th. Okay, so the reason why I mention that is when you look at the numbers 4 and 6, the number that you should have has to be at least 6. It'll be 6 or larger. Okay, so what is the number that 4 and 6 both go into, the smallest number? 12. Okay, so your least common multiple is going to have 12 in it. And then x squared and x to the 4th. The same thing applies here. Okay, it has to be the biggest one, because could I multiply something by x to the 4th to get to x squared? No, not without it being a negative number. Okay, so this is going to be x to the 4th. And between y cubed and y to the 5th, it would have to be y to the what? No? No? So see how x to the 4th? Oh, you guys are thinking times 2. With 3 and 15, what can I multiply by y cubed to get to y to the 5th? What do you do with the exponents? You add them. So this one is going to be y to the 5th. So with the exponents, you have the largest number. I'm sorry that looks terrible. It's y to the 5th. No. Yes. So the exponents are different than the number. Okay, so this one is 4x cubed, y to the 7th, and 3x to the 5th, y to the 4th. Okay, so for your variables, the exponent has to be the largest one between the two. Okay, so for 4 and 3, what is the least common multiple? 12. Okay, for the x's, x cubed or x to the 5th, which one do we have to use? X to the 5th, y to the 7th, y to the 4th, y to the 7th. The reason why these are different is because when you multiply variables, you do what with their exponents? You add them. So you could multiply this by y cubed to get y to the 7th. Okay, now we're also going to have this type. So you have x squared minus 2x minus 3 and x squared minus x minus 6. What do you think we got to do with those? Factor! Get ready to factor! Alright, let's do it. These aren't bad, right? We're getting really good at these. When it's your time for the picture, you can just go. It's fine. Okay, so if you have x squared, x and x, multiplies to negative 3, adds to negative 2. Negative 3, positive 1. You factor for that one, okay? Hey, Kaden, we just leave the door slightly open because I think people are going to come in and out. All right, well, multiplies to negative 6, but adds to negative 1. Negative 3, positive 2. Yay. Okay, so for the LCM, this one's a little bit different. But finding the LCM actually is not that bad. So just start here. These are all factors, okay? If this is included as a factor, it has to be part of the LCM. So start here with x minus 3. X minus 3 has to be part of the least common multiple because it's a factor. X plus 1 has to be part of it because it's a factor. X minus 3, if it's already included, you just leave it. So you don't write it again because that would make it too big. You already have it, so we'll just move on to the next one. X plus 2. So this is going to be your least common multiple. Okay, so the least common multiple is always going to include all of the factors. You just don't have to double them if they occur more than once. So for D, we have x squared minus 4 and x squared plus 5x plus 6. Okay, can you guys factor those two? Alright, do you remember this guy's a special pattern? X squared minus 4, what does that factor to? Yep, x plus 2, x minus 2. Good. Now this one, start with x and x. What multiplies to 6 but adds to 5? 3 and 2 or 2 and 3, does not matter which order you have them in. Same thing with the LCM. It does not matter what order your factors are in because you're multiplying. Okay, so the order that you multiply them in does not matter. Okay, so for your LCM, we can just start here. So it has to have x plus 2 in it. Has to have x minus 2 in it. Has to have x plus 3 in it. And we already have the x plus 2, so this is going to be your LCM. Okay, so we have to use this in example 3 when we start to multiply. We'll multiply to add or subtract. So adding and subtracting does require multiplication when you do not have the common denominator. So we're going to add or subtract, okay? And we do have to identify x values for when it's undefined. Okay, so we are going to have to make sure we look at that denominator, okay? Now, I'm going to give you a list of how to solve these problems. All right, so if you ever get stuck, you can come back to the list. It will tell you what to do. So the first thing you want to do is factor. We do this to the denominator only. You don't have to worry about doing it to the numerator, okay? At least not yet. Then you are going to find, you can call it the LCM or the LCD. We are going to have a denominator. The LCM is the LCD, least common denominator. Okay, and then once you do that, you multiply to get your LCD. That's going to change depending on the problem. Once you do that, then you can add or subtract or combine your like terms, CLT, and you do that in the numerator. Because remember, the denominator is going to stay the same. And then if you can simplify, you will. Some of them will, some of them won't. Simplify if it's possible. Okay, so we're going to go through these steps. So the first thing we're going to do is factor the denominator. So go ahead and factor what you can in the denominator, and then start thinking about that LCM. So you're looking for two values that multiply to -4 but add to +3. What are they? Yeah. And remember how I told you yesterday, like use your context clues, right? If this is x plus 4, try something with x plus 4 first. Okay? All right. And then your LCD for this is going to be x plus 4 times x minus 1. So x plus 4, x minus 1, that already is there. So when you are doing this, I'm going to write this out as factors. This is plus 2x over x plus 4. Okay? All you have to do is multiply by what is missing from the LCD. Okay? So all we did here is we just rewrote this with the factored denominator. Now we're going to multiply, okay? So what part of the LCD is this one missing? Okay, so we're going to multiply the top and the bottom by x minus 1, and then we'll have the LCD, okay? So the first one we don't have to do anything to. This one we're going to have to multiply. So the first one, I keep it the same, and then plus 2x times x is 2x squared, 2x times -1, -2x. And then just leave this on the bottom factored. Okay, then we'll combine our like terms. So 2x squared, I have x minus 2x, which is -x, and then I have -3. Now the simplifying process means if you can factor this, you're going to factor. Because sometimes things will cancel out. Alright, so let's factor this. We have x plus 4, x minus 1. So I have 2x and x. I need something that multiplies to -3. So it has to be a plus and a minus, 3 and a 1. Okay? So it has to add to -1. What are you guys thinking? So it has to add to a -1. What if I put -3 here? This would give me -3 inside. -3 times 1 is -3. 2 times 1 is 2. -3 plus 2, is that -1? Yep. Does anything cancel out here? Anything I can cancel? Nope. So this is going to be your final answer, and then you have to say what the restrictions are. Okay, so this is where x cannot be what? Just keep it slightly open for me too. So what can't x be here? Yeah, it can't be -4 or +1. Okay, and that comes from both. I know you're getting good at those, so. Alright, let's try this one. Now this one you don't even have to factor. Okay, there's nothing to factor here, so let's just identify the LCD. Okay, so what's my LCD going to be here? Two x plus 1? X minus 1. So just start on the bottom, right? That has to be part of it. X minus 1 has to be part of it. So now we're going to multiply each one by what it's missing. So if 2x plus 1 is in the denominator, I have to multiply this one by x minus 1 over itself, because that's a 1. That's why I can do that. On this one, I'm going to multiply by 2x plus 1 over itself. Okay, and remember, the denominator you can keep the same. So go ahead and write out what the numerator is going to be. So do your distribution. Alright, how's the multiplying go? Alright, so x times x minus 1 is x squared minus x. On this side, you have plus 6x plus 3. So let's just combine our like terms, and then we can put that over the denominator. Okay, so this would be x squared. Negative x plus 6x is 5x plus 3 over, and again, the order that you put the denominator in does not matter. Okay, either one is fine. Okay, and then we will see if we can factor this. So if I try to factor, I have x and x. The only thing that multiplies to 3 is 1 and 3, right? So is that going to make 5 in the middle? No, that would make what? 4. So this is not factorable. So if it's not factorable, this would be your final answer. You have to leave it as your trinomial, okay? And then you still have to figure out what x cannot be. So this is where x cannot be. So what would you plug in here to make this 0? What would you plug in for x to make that 0? 1. So x can't be 1. Okay? You can also set this up and solve, that's fine. Same thing with 2x plus 1, right? That means x can't be negative 1/2. Okay? Alright, you ready for subtraction? Ready or not, here we come. Alright, so for part C, we have 2x squared minus 30 over x squared minus 9 minus x plus 5 over x plus 3. Alright, so remember our first step is to factor, but you only have to factor the denominator. So you don't have to worry about pulling the GCF out here. Okay, we can just go ahead, factor the denominator. So we have x plus 3, x minus 3. Okay, so the LCD is x plus 3 times x minus 3. So what do I have to multiply by this? By that whole thing. Yeah, so let's just do that here. So we're going to multiply the top and the bottom by x minus 3. Now, when you multiply these two together, you're going to have to do what? You're going to have to FOIL. Okay? So I'm going to write that down here. I'm going to keep the minus, and then whatever I get when I FOIL, I'm going to write here. So x times x is x squared. I like to do the inside first. So that's plus 5x minus 3x. That's going to give me how many x's? So 5 minus 3 is 2. And then this will be minus 15. And then the front is going to stay the same. Now, I like to write it like that so I can remember to do what? Yeah. And if you want to do this part like without the denominator, put it back on at the end, you can. Okay, so you change this to a plus and then you distribute the negative. So 2x squared minus x squared, what's that going to be? 2x squared minus x squared is just x squared. And then negative 2x, nothing to combine it with. Negative 30 plus 15 is negative 15. The denominator, x plus 3, x minus 3. Okay, and then let's see if we can factor this. So we're looking for two values that multiply to 15 but add to negative 2. Yep. What are the signs? Yep, negative 5, positive 3. Ooh, what makes that kind of special? Yeah, something we did yesterday. You guys ready to cancel? Want to add some ASMR to your canceling today? Is that fun or no? Do we get any record fun? Somebody was talking about that yesterday. Okay, and then let's find out what x can't be. Now remember, you have to do that before the cancellations. So x plus 3 can't equal 0, x minus 3 can't equal 0, so what can x not be? 3 or negative 3. Okay, so you make sure that you put both of them in there. And again, that's because if this was 0, you'd multiply the whole thing to 0, you won't be able to cancel it out. Okay? Alright, you want to try one on your own? You've been waiting for this moment to shine. Show us you can do it. 3x minus 2 over 2x plus 5 minus 2 over 5x minus 2. Oh, I was going to tell you about another strategy you can do for subtraction. If you want, you can change this to plus right away. Just change it to plus and distribute the negative there. So you could do that. Or you could distribute the negative later. Either one. Okay? So our LCD has to have 2x plus 5 and what else? 5x minus 2. So set up what you're going to multiply by. Okay, and then you'll distribute and FOIL. So you know how to find your LCD? So these are the factors. So one without x, it'll be a factor. So it'll be 2x plus 5 multiplied by the 5x minus 2. So then this is missing this one, right? So we multiply by that. But then this one is missing this. So we multiply by that. And when you guys are multiplying, if you want to put these in parentheses, because we're used to foiling when those are in parentheses, feel free to do that. I like to do that. Just remember, your denominator is going to stay the same. Okay, so sometimes what I'll do is I'll just write out the numerator first. 5x times 3x is 15x squared. And then I have negative 6x here. And then on the outside I have negative 10x. And then I decided I wanted to line these up to combine my like terms. And then negative 2 times negative 2 is positive 4. And then I'm just going to continue lining up my like terms. So negative 2 times 2x is negative 4x. So I'm just going to put that in that column. Negative 2 times 5 is negative 10. So I'm going to put that in this column. That way I can just go down and I don't have to worry about simplifying across. So this makes negative 10. Negative 10 and negative 10 is negative 20. 4 minus 10 is negative 6. Okay, so this is your numerator. And guess what? It's not factored. So you're just going to keep it 15x squared minus 20x minus 6 over 5x minus 2 times 2x plus 5. And then, of course, we have to say what x cannot be. All right, so if we have 5x minus 2, that means x can't be 2/5. And if you have 2x plus 5, that means x cannot be negative 5 over 2. All right, enough of that. Let's do some simplifying. Simplify some fractions within fractions. Okay, what questions do you guys have for me on the subtraction rational function?
So you only factor the numerator or
Denominator, yes. If you can factor the numerator here, you would, but this one is not factorable. Okay, so, and you would have to guess and check. Okay, and then nothing would factor there. Okay, so then you just keep it. But sometimes it will. Okay, all right. For the next one, we are simplifying, and we can assume for this that all expressions are defined. Yay, that means that what? What don't we have to write for that? Yeah, we don't have to worry where x doesn't equal a value. Okay, you guys ready? Prepare to be amazed. To see a fraction within a fraction. Okay? And we are going to leave these in factored form. Okay, so your final answers for these will be in factored form. Okay? Alright, so for A we have x plus 2 over x minus 1. So we're going to start with that. And then that is divided by x minus 3 over x plus 5. So we're going to use what we talked about yesterday, that division is just multiplying by the what? Yeah, multiply by the reciprocal. So we're just going to take that first fraction, write it the same way, and then we're going to multiply by the reciprocal of the denominator. Now sometimes things will cancel, sometimes they won't. So if you multiply straight across, again, I said you could leave this in factored form. That means you only have to write it like this. You don't have to FOIL it, okay? So you can leave it like this. You do not have to FOIL. All right, let's try B. So we have x plus 1 over x squared minus 1. And that is divided by x over x minus 1. Okay, so if you can factor, you will. So when you rewrite this one, okay, the top is x plus 1 over, let's factor this. What is x squared minus 1 factor to? Yep, x plus 1, x minus 1. Good. Remember, that's one of our special patterns, guys. And then we're going to multiply by the reciprocal, x minus 1 over x. Now for this one, we have some cancellations. You guys ready to slash them out? X plus 1, does that cancel? What gets left in its place? 1. Okay? Alright, so what's the top? 1. What's the bottom? Yes. And that's all you have to do. So that's not too bad, right? Oh, Miss Buckle, it's not too bad. We can do it. We are the smartest kids in the school. We can do anything. All right, now let's just throw another fraction in there. Both of you guys are going like okay, so what we were doing before is we were just multiplying by the reciprocal. That's because this was one term. This guy here is 2 terms. So what we're going to do is we're going to add this first. So we're just going to simplify the top, then it becomes just like the problem we did before. Okay, so add to make one term. Then we'll do the division, okay? So I know that can be a little overwhelming seeing it all together. So let's just separate it. Let's just say, okay, I'm just looking at 3 over x plus x over 2. What's the LCD? To what? To x, okay? So your LCD here is going to be 2x, which means you have to multiply the first one by something and the second one by something. So if it's 2x, what do I have to multiply the first one by? 2 over 2. What do you multiply by 2 to get 2x? X over x. Okay, so if you do that, 2 times 3 is 6. So 6 over 2x plus x times x is x squared. All right, so this is our new numerator. I thought we lost you. Okay, so if this is your new numerator, okay, I'm just going to write this in standard form, and we're going to do the division. Okay, so we're going to take the numerator, x squared plus 6 over 2x, and now we're going to multiply by the reciprocal. What's the reciprocal of x minus 1 over x? What would go on top? X minus 1 on the bottom. Okay, so once you simplify the numerator, right, then it just becomes the same problem as before. Anything we can cross out? There's one thing. Yeah, the x. Okay, so that means the top is x squared plus 6. The bottom is 2 times x minus 1. You can't cancel out the 2 because this is plus. Okay, if this was times, then yes, you could do some simplifying there. Okay, but a plus or a minus stops that from happening. Yep.
Why would you cancel it out with the x with the 2 instead of the x with the 1? Like below. Like, cancel out with this x instead of this x.
Oh, okay, so this is just an x by itself. This one you can't because it's attached to the minus 1. So you have to think of this as a group. This is a group here. Because this doesn't have anything added or subtracted, that's why you can cancel. Yeah, and that's a good way to think about it, like in the parentheses there. All right, and then D, we have 1 over x plus 1 over 3x divided by x plus 4 over x squared plus 7x plus 12. So this is another one where we're just going to separate the numerator and denominator. We're going to deal with them at different times, okay? So we'll just simplify the numerator first. So to simplify the numerator, this is very similar to what we did in problem C. What's going to be your LCD for the top? X will be part of it. What else? 3. Okay, so this one already has the LCD, so what do I have to multiply here? Times 3, because 3 times x is 3x. Okay, so then I have 3 times 1, which is 3, plus 1 over 3x, which is going to be what? 4 over 3x. Okay, so we did it. We simplified the numerator. That's great. Now, we're going to simplify this guy. So we can factor here, x and x. We're thinking, okay, it has to multiply to 12, add to 7. What comes to mind? 3 and 4. So plus 3 plus 4. Okay, so we have x plus 4 on the top divided by x plus 3 times x plus 4. Now you can decide, you can cancel out now or you can cancel out in the next step. Okay, it really does not matter which one you do. You guys have a preference? So the top's going to stay the same, right? And then we're going to do times. We'll cancel it out here. Make sure we don't miss any cancellations. You guys ready to slash them? We're slashing prices and expressions with x in it. Okay, and then in the denominator we just have 3x. Okay, so we can't cancel those out because this is an x plus 3. Okay, and then this is just our final answer. Alright, so believe it or not, rational functions have a real-world application. And we got to change the bottom tab a little bit. That's why I'm smiling. Because it should say 1.4, but we'll do that together. So we can use the skills that we just did above to find out an average speed, okay, when you have 2 different speeds on a trip. So a hiker is actually going 1.4 miles an hour, not 14. They're not that fast. Okay, and that's when they're going downhill. Okay, and then 0.8 miles an hour walking uphill. Okay, so we have two different rates. Okay, and this makes sense, right? When you're going downhill, gravity is helping you, so you're walking a little bit faster there. We have to find the hiker's average speed for the entire trip. We are going to round to the nearest tenth, and this is one that you would be allowed to use your calculator on if you have decimals, okay? So in order to solve this, we have to think of this common equation. Do you guys know the distance equals what times what? Speed times. We call it the rate multiplied by the time. The rate is the speed. Don't you guys remember from science, you did a lot with D equals RT, like that? Distance equals rate times time. You didn't do it this year, did you? Okay, so the distance equals the rate times the time. So what we're going to do is we're going to use this equation to help us set up a problem, to model the problem for the distance, the rate, and the time, okay? So first we're going to think of the total distance that they're hiking, okay? So we're gonna give the variable d. That's going to be the distance one way. And the reason why it's only going to be the distance one way is because we have two different speeds, okay? So let's draw our hill here. Just so happens it's perfect parabola. Oh, that looks a little steep. All right, so, really they would be walking up the same way, just FYI. Walk up and then they walk down the same way. That's how we know it's the same distance, but for parabola purposes, this is what we got. So on the way uphill, they are going 0.8 miles per hour. And then on the way downhill, they're going 1.4 miles per hour. So the total distance here, okay, because they're going one way up and one way down, d plus d is, so you're going uphill and then you're going down, right? So d plus d is going to be 2d. Okay, so that's your total distance. One d going up, second one going down. All right, now we're going to talk about the time. Okay, so the time can be modeled by the following equation. If you want to solve this for time, what would you do to both sides? Yep, so the time is represented by this equation, okay? And you're going to have this, so you can always use this. The time is the distance divided by the rate. Okay, so what we're going to do is we're going to model this for going uphill and going downhill. So you're going uphill plus downhill. This is very similar to what we did here. We did up and then the down. Uphill, the distance is d. That's what we said, right? The distance up is d. The rate uphill is what? 1.4. Plus, downhill, you're going the same distance, but now what's your rate? 0.8, yeah. Okay, so this is your total time. Okay, so we found the total distance. We found the total time. And our last step, we're going to put them together, and that's going to be for your average speed. Okay, so for the average speed, That's your rate. Your rate is equal to, do we know what your equation is for the rate? If you solve that for R, it would be what? D over T. So the distance divided by the time. Okay, so the average speed, we're going to take into account the totals. So the rate is going to be the total distance, 2D, over the total time, which is D over 1.4 plus D over 0.8. Okay, so now this is what we're going to do. We're going to solve like we just did before. Okay, so the numerator, nothing to simplify. But in the denominator, what do we have to get? We have to get a common denominator to add these together, right? The common denominator is just going to be those two guys multiplied together. So let's do 1.4 times 0.8 in our calculators. We're not going to be heroes today. I'll just tell you, it's 1.12. You guys trust me? Good. What did you say, Ashley? Yeah. All right, so you have 2D on top. So if I multiply 0.8 times D, you just get 0.8D plus 1.4D. And then the denominator, when you multiply those, is 1.12. And then remember, to solve this, you just multiply by the reciprocal. So it's 2D times 1.12 over, and then you can combine these. 0.8 plus 1.4 is 2.2. What happens with the D's in this step? They cancel. Okay, so then you would just do 2 times 1.2 divided by 2.2, and you should get approximately 1.0 miles per hour. Okay, so you have the 0.8 and the 1.4. This is going to be the average speed of the entire trip. Okay, Steve, can I borrow your calculator for a second? I'm just going to show here. Okay, so to get that, you do 2 times 1.12 divided by 2.2. So it says to round to the nearest tenth. This one happens to be the 1.0. Okay? Okay, and then your homework is on your calendar.
Couldn't you just 1.4?
No, do it.
0.8, and then you divide it by 2? That would be your average.
No, that's a common round thing to do.